Hey everyone, my name is Cedric. You can call me Prof. Ced. I'm here to teach you some math. We're going to go from sessions 1 to 6. If you're here, it's probably because you want to do well on the math. I'm pretty sure if you watch all these videos, you'll get that 20 out of 20 that everyone's hoping for to up your average. The topic of today's topic will be functions and graphs. But before we get into that, the first thing we have to know is the different names and what they correspond to. So the different letters. So obviously we have here the natural numbers, the integer numbers for Z, rational numbers, real numbers, imaginary numbers, and complex numbers. In the textbook you can find lots of examples to explain what it is. These are very important to note because it comes up often, especially in the math we're doing here at ESSEC. Now that you have seen this, okay, and understood this, let's move on and recap on what you have learned during high school, or should I say lycée. Shown on the screen here is basically something called exponents. So over here we have, obviously you can see x to the power of n. X is regarded as the base and n is to the power of. So an example of this would be 5 squared. 5 would be the base, and therefore the 2 would be the exponent. Anything to the power of 0 is going to equal to 1. These are just some rules that you will have to learn because it comes up different later in the sessions. But here are some examples that you can try from A to E. If you do have any questions on how to do these, you can find me on campus anywhere. Just tap on my shoulder and I'll be able to help you with this. So as well, there's something called radicals. Radicals are in fact basically just exponents, but just a division. So basically x to the half instead of x squared, it has the division. So basically over here I put lots of laws that you can look at and you can understand. And as I said, if you guys have any questions, you can come towards me. I would suggest you doing, out of the 20 questions, I suggest you doing 5. This would be good practice for the exam to come because the teacher, Mr. Dragoslav, he will definitely put this in the exam. An important skill to have is something to rationalize. So here we have 3 different questions. I want you to make it not negative and make it all positive. Because that is a skill to have and it's a skill that people will use for math. Moving on, let's go on to functions. This is your f of whatever is equal to y. A good way to understand what a function is, it is what you put in is what you get out. So what you put in is going to be like your domain, which is your x values, and your range will therefore be your y. That's a simple way of looking at it. Here's an example of the function. And here, onto the below as some good practice. So this is the f of z. Now moving on to the f of r squared, you just plug and play. So 3r squared to the power of 2 minus r squared plus 5. Because you're replacing anything from r and z into x, and then you move forward with that. So this would therefore be 3r to the 4 minus r squared plus 5. Then moving on to f of x plus h. This is important for later when we're going to be doing derivatives and integration. So I won't go through it with you now, but I guess you'll see that in the future, eh? Now after looking at all these functions, we then move on to something called linear. It's pretty simple, linear function. Linear function, okay. Back home in South Africa, where I was told we would call this y equal to mx plus c, okay? So here's your graph, boom, boom. A linear function looks like this, okay? So your gradient is the change between here to here, and your c is this over here, okay? But how do you calculate your gradient? Your gradient, an easy way that we learned is called rise over run. So let's say we have 2 points here. Let's call this 1 and 4. And call this 3 and 6. To find your gradient, this is what you do, okay? You see how much your point has risen by and how much it has run across by. So you can see that from 4 to 6, it's risen up by 2, and it's run across by 1, 2, 3, 2 as well. So therefore, your gradient is actually 1. That's a simple way to look at it for gradients. But how would you find your intercept? Your intercept, so now that you have your gradient, you take this number, plug it into m, so you get y is equal to x plus c, but you have y and x because you have an example there, so your y, if your y value is 6, it's equal to x plus 3, therefore your x is equal to 3. Thus, your formula for this particular graph is therefore going to be y equal x plus 3. That's the most simple function you're going to come across. It is asked in the exam, so I advise you to look at it over and over again. If you need more examples, as I said again, you can come over through campus to look for me and ask. Now we even move on to something called the quadratic formula, which uses quadratic equations. Okay. Moving on, now we have the quadratic formula. The vanilla, this is what we like to call a function, which is just in its normal state with no movements at all. That would be a x squared plus bx plus c. That is your vanilla function. What I mean by vanilla is that it's all simple for the moment, but once you start adding and changing the a, the b, or the c, that's where things start to get difficult and complicated. The way to find this is you're given a function, therefore after you're given the function, all you have to do is plug in and play. And usually to find these numbers, what you also have to do is you have to make everything equal to 0. So if you're given a function, you make it equal to 0 and then you solve for it. Finally, we move on to exponential functions. So in terms of exponential functions, the vanilla formula for exponential functions is y is equal to a to the power of x. But you can usually change this and add intercepts, but you can also change it in the way the graph is shaped. Okay, so over here in the 3 graphs in the photo, you can see that the first one is just a vanilla one like this, but now you get a concept called y to the e of x. So e is just an imaginary number, normally based between 2,14, and this number it's not necessary to know, but e is a really important number when it comes to doing derivatives, which we will get into at the later stage. Thank you for watching the first session, and I hope you understand it. So that's the end of session 1. If you guys did try these examples and you're happy with it, then you can come find me and I can just mark it for you, and if there are any faults I can explain to you. Don't hesitate to come contact me. I'll be in the cafeteria most of the time, so if you just see me, you can ask the questions. Alright, I'll see you guys at the next session.